Hello, today's topic is on modulo arithmetic and our core mathematics. Modulo arithmetic and our core mathematics. Now, we are going to deal with integer for a given modulo. So we are there with the application. We are now going to deal with the integers for a given modulo. So for instance, the division of any integer by 4 are 0, 1, 2, 3. So if I divide any integer by 4, the remainder that we want is what? From 0 to 3. Because know that 4 mod 4 is 0. Okay, 4 mod 4 is 0. So then other number, maybe we have 5 mod 4, we get remainder as what? 1, and so on. So you are saying that, for instance, if we divide any integer by 4, supposed to have 4 digits starting from 0 to 3. Start from 0 to 3, not 4. That's the set of integer. So that's the remainder we are talking about. The divisor 4 in this case is called the modulus, and the arithmetic is said to be mod 4. So when you say mod 4, the remainder that we are expecting is 0 to what? 3. Is 0 to 3. Okay, good. Mod 4 can therefore take one of the value 0, 1, 2, 3. Talk about that one. Otherwise, mod 6 can take this. So from 0 to what? 5. So mod 12 will be what? 0 to 11. Good. So very simple. So in modulo, always remember that we are dealing with the remainders. 8. For finding a modulo. If the dividend is less than the divisor, that's the modulo number. If the dividend is less than the divisor, the dividend remains the answer. For instance, so 5 mod 7 is 5, 3 mod 8 is 3, and this one, I've talked about that one. Mod 5 of all numbers ending in 0, 1, 2, 3, 4. So the last, that's what the last, okay, or the ending digits. So we talk about that one. Mod 5 is from 0 to 4. That's what mod 5. That's the remainder. Okay, so 12 mod 5 is 2. 12 mod 5 is 2. 117 mod 5. So that one, if you are using the repeated subtraction, then you will get what? 0. But if you divide 170 by 5, you had 0. So if you had a number, so the remainder is what? 0. Good, and so on. So we are still on modulo. Modulus of a negative number. We dealt with negative number the time that we are doing with application. By now, we are going to do it this one. So we are saying that for a negative number, we have to add the modulo until we get a positive number, which is less than what? That of what? The modulo. Okay, good. So I have an example here. Negate mod 3. Negate mod 3. So I have to add the 3 until I get a positive number, which is less than the 3. So that's called the repeated addition method. So negate plus 3 is negative 5. So we have a negative number. So I have to add negative 2, still add a 3, then it's 1. Then it's 1. And 1 is less. So therefore, our answer is 1. 2. Neg 38 mod 12. So neg 38 mod 12. So neg 18 plus 12 is neg 26 plus 12. Neg 14 plus 12. Neg 2 plus 12, 10. And 10 mod 12 is 10. So the answer here is 10. Neg 61 mod 9. Neg 61. So you add until you get what? A positive number. Try this for me. And your answer is 27. 27. That's modulo of what? A negative number. Our next subtopic is equivalence or the congruence of what? A modulo. In modulo arithmetic, two or more integers are said to be equivalent if they give the same remainder under the same mode. Good. So you have two or more integers and we get the same remainder under the same mode, then you can say that these are what? Equivalent or congruent. Determine whether the following pair of numbers are equivalent in the modulo given. 1. 29 and 77 mode 6. So we have 29 mode 6. I'll start with the 29. 29 mode 6 is 29 divided by 6. So you can use the repeated subtraction or the mixed fraction. So now you know how to do it. Good. So 4 times 6 plus 5. The remainder here is what? 5. So the answer here is 5. Please learn how to use the mixed fraction or the repeated addition. And when it's negative, you don't use the repeated addition. But when it's positive, you use the repeated subtraction. As time go home, you will do it. So 77 mod 6. So that is 77 divided by 6. So I'll use the mixed fraction here. 12 times 6 plus 5. The remainder here is still 5. So you can conclude that same as 77 mod 6 is 5. Then it's a congruent or equivalent. 29 and 77 mod 6 is the same as or is congruent as 5 mod 6 is 5. So we can write it as 5 mod 6 is 5. Good. So 29 and 77 mod 6 is equivalent to 5 mod 6, which is 5. 2. We have 19 and 30 mod 7. So I'll start with the 19 first. So 19 mod 7. So we did it individually. 19 mod 7. 19 divided by 7. You change to mixed fraction. The remainder here is 7. 5 rather. The remainder is 5. 30 mod 7. That's 30 divided by 7. And the remainder is 6. So they are not the same. They are not the same. They are not the same. So this one is not congruent or equivalent. So 19 mod 7 is not equals to 30 mod 6. And this one is not equivalent or congruent. Since you have done a lot of working on modulo, let's solve arithmetic under modulo. That's modulo operation. So now we know how to deal with whether positive, negative of a modulo, whether we use the repeated subtraction, repeated addition, or the mixed fraction formula. So in modulo, you always deal with the remainders. Good. So we are going to do this one. So I'll just do it and then you give me the answer. So 1, 14 plus 4 mod 4. So 14 plus 4 is 18 mod 4, and 18 mod 4 is, so you can use the mixed fraction or you can use the repeated subtraction. So what's the answer? 2. Good. Or we can say that 2 mod 4 is 2. We talk about equivalent or congruent. So we can write this one as that. 13 plus 33 mod 8. That's 46 mode 8. So do that one for me too. 46 divided by 8 and plus what? And what will be the remainder? So the remainder is 6. Good. 26 minus 9 mode 6. That is 17 mode 6. You can subtract until you get a positive number which is less than the 6, or you can use the mixed fraction. And what's the answer? Good. The answer is 5. 12 mode 34. 12 minus 34 mode 8. So here we had a negative 22 mode 6, and we deal with negative numbers. Okay, so you have to add until you get a positive number. So negative 22 plus 6 plus 6 plus 6 until you get a positive number. I'm waiting for your answer. And this is the answer. Nice. 13 times 33 mode 5. So 13 times 33 is 469 mode 5. 469 mode 5. So this one, if you want to use the repeated subtraction, you subtract. So that's why there's a mixed fraction there for you. So 469 divided by the 5, then you look for the remainder, and that is 4. 300 divided by 12, 25 mode 5. 25 mode 5, and that will be 0. So you will not have any remainder. Okay, this 25 mode 5. Good. We don't have any remainder. Now it's 25 mode 11. 25 mode 11 is 25 mode 11, and which is 3. Then we have 78 divided by 2. Then we have 38 mode 4. The remainder is 2. Nice. So that's for the modulo operation. Very simple and very interesting topic under modulo. We are going to do modulo in a given equation. That's modulo equation. So step in solving for modulo in a given equation. Step 1. You find the difference between the numbers given. 2. Find all the factors of the difference identified. And we know how to find the factor of a number. Yes. Substitute each factor into the equation to make the statement true. Okay, so you just find the difference, you find the factor, then you substitute each factor into the equation to make the statement true. So let's see how it goes. If 2 equals 12 mode s, find the value of s. So what value of s will give 2? The remainder as 2. So the value of s mode 12 will give us the remainder as 2. We don't know. So the first step, solution, they say we should find the difference. That's the first step. So the difference between 12 and 2 is 10. Then you find the factors of what? The difference, the number. So the factor of 10 is 1, 2, 5, and 10. This is the factor for 10. We all know how to find factors of 10. So 12 mode s is 2. That's the question. 12 mode s is 2. That's what they are saying. And you want the s. So the factors, in place of the s, we just have to in the factors in there, one after the other, until we get what? 2. So the first one, 12 mode 1. We start with the factors. So the factor of 10, 1. 12 mode 1 is 0. Okay, because 12 divided by 1 is 0. That's the remainder. In modulo, we always talk about the remainder. Okay, 0. So there's no remainder there, so 0. 12 mode 2. 12 mode 2 is 0. If we divide 12 by 2, the remainder is 0. Good. 12 mod 5. So if you subtract 5 from 12, then what do we get? Or 12 mod 5. 12 divided by 5 is 2. So the remainder is 2. So we can use the mixed fraction rule. Good. Yeah. Because 2 times 5, 10 plus 2. 12 mod 10. And that one here is 2. Is 2. 12 mod 10 is 2. So you are there with all the factors. The factors in here. So you have 1, 2, 5, and what? 10. So you conclude S is 5 or S is 10. Why? Because 12 mod 5 we had 2. 12 mod 10 we had 2. So S is 5 or 10. So if S is 5, then you have 2. So 12 mod 10 is 2, or 12 mod 5 is 2. So that's the answer for this. With the same approach, find the value of S. In 12 mod S is 3. So you have to find the difference between the two. The difference here is 21. Then you find the factors of 21. 1, 3, 7, 21. These are the factors. And we all know how to find the factors. So the question, 12 mod S is 3. You just substitute the factors in each of them one after the other. 12 mod 1, the remainder is 0 because 12 over 1, there's no remainder. 24 mod 3, the remainder is 0 because 3 divided by 24, you get an answer. So the remainder here is 0, there's no remainder. 24 mod 7 is 3, that's the remainder. 24 divided by 7, so we know how to look for the modulo dealing with the remainders. 24 mod 21, 3. So 24 mod 21 is 3. So we had 7 and 21, all is 3. And that made the statement true. And 21, 7 and 21. We are still a modular equation. Example 3. Determine the modulo in which 6 plus 8 is 4 was performed. So you have to determine the modulo. Solution: 6 plus 8. So now I want the modulo. So you say 6 plus 8 is 4. So what modulo that we solve, we will get 4. We don't know. So that is what they are saying. So 6 plus 8 mod S. We don't know. We are looking for the mod S. So we write it like this. So from here we can solve. 6 plus 8 is 14. 14 mod S is 4. So from here we can apply our step in solving for modular equation. So you find the difference 10, the factors of 10, then you substitute it in each of it. So 14 mod S is 2. So let's see which of them made the statement true. 14 mod 1 is 0. 14 mod 2 is 0. 14 mod 5, because we are doing with remainder, so your 14 mod 5 is 4. Okay, so 14 divided by 5, the remainder is 4. 14 mod 10 is 4. And our S is 5 or 10, because 5 and 10 make the statement true. The operation was in mode 5 and mode 10. That's all. The conclusion, nice conclusion. 4. If 7S is 3 mod 6, find S. So if 7S is 3 mod 6, they say we should find S. So we don't know. What should we do? If 7S is 3 mod 6. It says we should find S. We talk about congruent or equivalence. So we can change this one as 7S mod 6 is 3. Okay, so you can change this one. So this one is the same as 7S mod 6 is 3. So in solving for this, you have to change this one. We talk about congruent in our previous videos. So 7 mod 6 so here you find the mode of 6, and mode 6 is what? The mode of 6 is from 0 to what? 5. Yes, we talk about this one. So just substitute this one into what? The equation until you get 3. Okay, 3. So here you will not find the factors. Okay, so you are given the mode, so you have to find the mode. At first we are not giving the mode, that's why we are finding the factors. So 7 times 0 mod 6, that 0 mod 6 is 0. Okay, 7 times 1 mod 6, that's 7 mod 6, the remainder is 1. 7 times 2 mod 6, 14 mod 6, the remainder is 2. 7 times 3 mod 6, 21 mod 6, solve it, the remainder is 3. This one mod 6, okay, and that's the remainder. 75 mod 6, that's 35 mod 6, and that's the remainder. So therefore, you can conclude that which one of them made the statement true? Which one of them made the statement true? So when S was 3, we had 3. So therefore, our S is 3. So this one makes the statement true. When S was 3, we had 3. And this is what we are talking about here. So that's how we solve for this kind of question. Bye. Nice to meet you. Subscribe to Snappers, my YouTube channel.